Welcome to part 2 of Competency 5. In this video, we will model and solve systems of linear functions. Number 1, 10 gallons of water are stored in a 14-gallon container. During the first 4 hours, the water evaporates from the container at a rate of 0.1 gallons per hour. During the next 5 hours, the water evaporates from the container at a rate of 0.3 gallons per hour. Which of the following functions represents the volume of water in the container at time t, where 0 is less than or equal to t and t is less than or equal to 9? Okay, what we are looking at is two different situations. Basically, a system. You have the first 4 hours, and then you have the remaining 5 hours, okay? And with that system, you have conditions. So this will make it more like a piecewise. Well, it is a piecewise function. Okay. That being said, we know that we can eliminate option A and B because we have conditions. The condition is the first 4 hours. So that has to be, as you see here in C and D, from 0 to 4 hours, and we are including the fourth hour. It is included in the first equation in the system. Notice that the English says in the next sentence, you always have to break down the way it's, said or written. During the next 5 hours. That implies that it's beyond the 4 hours. So we're not going to include the 4 right up to 4 hours, and then everything after that is in the second part. And I'm saying that because I need you to recognize that we don't have an equals. And that makes this, both of those, correct as far as splitting up the time limits. Now, where do we have the difference? Well, the first thing that you need to see is that you're not filling the 14-gallon container completely to the top. The 14-gallon part here in the first sentence, this is the name of the container. They could have said trough. They could have said large pitcher. They could have said anything. Vat, a big vat, or it could have been oil in a vat. It could have been anything. So that's a name, not a value we are using. Now that you know that, please recognize that the value that's originally in the container is 10. Okay, now that I've said that, go back and look again. Option C is where we see that 10. Option D, we see the name, the 14 pulled out of the container name, and that's incorrect. Okay. All right. It's all in how they state it. Now, you may be wondering about this 9.6 that are in both C and D. Well, what we need to do is actually calculate the first 4 hours. Okay. And what do we use for that? Well, we use the 4 and this 0.1. Okay, so 0.1 times 4. Okay, so that's 0.4. Now, if we follow through and actually apply that, okay, all right, and we say 10 gallons minus the 0.4 that is just evaporated in that first equation, that's where the 9.6 comes in. So starting right up front at the first of that last 5 hours, what is in the tank is 9.6 gallons, okay? And they could have just called that a tank. in all honesty, you could mark this out right here all the way and say, oh, here, let me just use another color and say that is a tank. It doesn't matter. And that also tells me that we have the correct option of C. Okay. All right. So let's look at number 2. A particular restaurant charges $9 for a large pizza and $1.75 for each topping selected. Let C be the total cost of a pizza and let T be the number of toppings. So it's T for toppings, okay? Which of the following is an equation for the total cost C of a pizza? Okay, don't be misled with this one, okay? Notice that our $9 is just what you're going to pay for any pizza. So that's like a starting fee. Okay, so we're going to call that a B value. So you're going to start with $9. Everybody has to pay $9. And then it's has the word and. So that's going to be our plus. And then notice this particular phrasing, $1.75 for each. The minute I see for each, I teach even, this is what I tell little sixth graders even, when you say a number like that and for each, that is indicating you probably have a slope. So that number, I bet, will go in front of an X. So I tell them when you see a for each, and this is in this particular kind of setup. Okay, it's just something I help them recognize. Put an X above that, and this we're going to call RM. Okay, this is what I'm trying to teach them, how to break down when they read over here. I was going to make that look more like a plus for you here. That I'm not sure what there. Yeah, okay, well, that's better than what I had. I don't know. So anyway, we have that. So if that's our M value, then we have 1.75x. And I need to look over here. Of course, you're not going to have the dollar symbol, and you don't have to have those zeros, but let's see what they've given us in our ABCD option. Okay, so they're all equal to C. Well, I'm looking, and my X needs to be a T. Okay, great. Well, now that I've looked at it, even at a quick glance rather, I think that that's A. Okay, now, I don't like B because that implies distribution, and that would mean that we're going to say $9 times the topping. That would be one of the most expensive pizzas ever on the planet. Okay, you could put that in your calculator and check it out. Okay, now C could it could fool you. You might be tempted here, but again, what this is saying is that we're going to charge you $1.75 for the pizza and then $9 for every topping. Those are expensive toppings. The pizza may be inexpensive at $1.75, but $9 for each topping. I think there would be some extremely angry customers. So let's mark out C and let's look at D. Okay, that's just multiplying everything together. The number of toppings times, oh, that's even more expensive. Wow. Yeah. That's $1.75 times 9 times the toppings. And where is my plus? And where is the initial cost of the pizza? So that is completely set up incorrectly. The minute you saw that it didn't have that plus for your and, you could see that's just a mistake, okay? All right, so let's mark that out. So yes, option A has been verified. And if you're curious, just to make sure, you could go ahead and put table, which is going a little bit far, I know, but while you're studying, it doesn't hurt to create these. So 9, I don't need those zeros. So 9 plus 1.75. And for the t, we need to put our x, okay? Remember, our calculator takes x, okay? Push enter, start at 0. Let's say I just want a cheese pizza, and we're going to assume they don't charge me for cheese. Even if they do, they're not going to charge me that much, okay? So let's start at 0 and push enter and enter. And let's look at how much that pizza would be. And this makes sense. The first pizza would only be $9 because I didn't want anything on it but cheese. And I was good to go. And not even extra cheese. Now, extra cheese, that's usually totally different. And I'm really digging into this whole pizza, right? Maybe we're all hungry, right? Okay, so if I want one topping, 10.75, two toppings. Now that would make sense if you're building this one by one. Okay. All right. Let's look at number 3. Number 3, find the solution of the following system of equations. Okay. They give us a nice simple system, and our options are all whole numbers. So this shouldn't be too tough to deal with. I would recommend, because you have minus y and minus and plus y. Sorry, I keep saying the wrong thing. You have this. Those two automatically create a zero pair. They're naturally eliminated. So then we have 1 plus 2 is 3x equals 15, and that gives me x equals 5. So we know that we need x to be 5. We have just eliminated 2 of our options. Now we need to discover which value of y do we need. So this is what I do. I take this and I go back up and put it into any of these, but, well, either way will be fine. Watch this. Okay, I could turn that into, y-intercept form, or just come over here and pencil it and then put it in the calculator and verify again. Okay, so if I have 5 for my x, okay, plus y equals 7, obviously I'm going to subtract 5 from both sides, and y equals 2, and this gives me c. Okay, that wasn't too bad. Pretty small numbers. They already gave it to you in a very simple form. Now, there is another way to use our calculator when it gets a little bit more challenging, as it is in number 4. Okay, so let's go give ourselves some room. Okay, so what do we need to do with number 4? Well, I would take this second equation, because it's a little more simple, and create my y-intercept form, and by just subtracting 3x on both sides. So that gives me a solid expression to put right back in for y into the first equation. Okay, so now what do I need to put into my calculator? Well, this is what we need to put in. We need to put in our 2x minus 3. Now we are going to replace the y. However, we need to deal with this equals 7. Well, that's simple. Just subtract 7 from both sides, which makes it equal to 0. And that's what we've got. Okay, remember, you are substituting the expression you created with the first one. Yes, we are using substitution. So let's do this. Okay, let's go to table, and let me go ahead and clear all that out and retype. 2x minus the 3 in parentheses, the 5 minus 3x, close my parentheses, and now we're subtracting the 7. Okay, push enter, and we want to start at 0 and go in steps of 1. Now, we also need to be aware of our options. We have whole numbers, or rather integers, whole integers. And then we have many solutions and no solutions. Now, how do we know if it's many solutions or no solutions? Well, before we go any further, we probably ought to talk about that. For many solutions, the two equations in our system would have to be like you could would have to multiply, okay, and then they would have to be the same expression. Well, I just don't see that happening, because if we multiply the first one by 3, then we have to multiply the next one by 2, and that will not give us the same numbers all the way, all the way across. We would have to be able to either divide down or multiply up, and that's just not going to work. So that's not copacetic. So I doubt it's going to be the same line, which is many solutions, which is infinitely many solutions because of the same line. I disagree with that. Now, no solution. How do you know about no solution? Well, no solution would mean that somehow we would have to see the same slope when we put these in y-intercept form. And I'm looking at these, and I know you need to work them out, but I'm thinking that when we try to create that, we would have -3, 2 divided by -3, and anyway, it'd be a -2 divide. Anyway, doesn't matter. I don't see the same slope. You can check that, but I disagree. I'm thinking that when I put this in, I'm going to see that I need the x value of 2. So let's keep going. Push enter, enter, enter. Okay, 2 is 0. So that's correct. Now, what do I need to do? Well, just go up here. Now that we have verified the 2, you substitute for x equals 2. Okay? So we can just pop that in the calculator. So second mode, I need 5 minus 3, and in parentheses, I need my 2, push enter, -1. Option B is correct. I think they were trying to throw you off with the many solutions and no solutions. That's a very popular thing to do. They're trying to test to see if you know what it means to have the same line, meaning they would just be one right on top of the other, or are they parallel, which is no solution and same slope? Okay. All right, let's try number 5. Number 5, find the solution of the following system of equations. Okay. Before we begin, we need to look at C and D. Okay. If we can multiply, quote unquote, up or divide down, then we would have the same line for both of those, or one line on top of the other, and that would be many solutions. Well, looking at that, I don't think that's a possibility. I mean, even if we took this second one here and multiplied it by 5, well, no, and then this one by 2, uh, I don't know if I'm seeing that. Well, we could try it. Let's see. This one, the first one times 2, well, that would give us 10x plus 6y equals 18. Okay, but then the second one, if we divided it by, I'm sorry, multiplied that by 5, yeah, I'm going to have 10x. But then I'm going to have -20. No, definitely not going to work. So you might want to just try that out, pencil it out real quick. So I know, okay, and I'm going to go with that they're not the same. So the many solutions is gone. Usually it's pretty obvious, because it's just sometimes it's a quick multiple, but not always. Okay. Now, no solution means we would have the same slope. Um, if we put those in y-intercept form, I just don't think so, because if I have negative 5 divided by 3, and then the other one would be negative 2 divided by negative 4. Definitely not the same slope. So I'm going to disagree with D. And let's just follow through like we would normally, okay? So what am I going to do? I'm going to take this first equation and I will put that in the y-intercept form by taking 9 minus 9 and subtracting that 5x I was kind of talking about earlier. Now divide each by 3 so we can see it quickly. Y equals, well, that's 3, and then minus a 5 over 3x. Okay, so we take that expression, and we're not worried about the fact that it's a fraction at all. Even if you kept our first, above where we're trying to simplifying it and kept that as a whole fraction, it's fine. So the point is, now we have something to substitute into the second equation. So we take all of this y and we substitute it here. So into the calculator, what do I have? I have 2x minus 4, and I will substitute all of the y, okay? And then I need to deal with equals 14. We'll subtract 14 from both sides of the equal, and this is what you get. You get at the end, you get a minus 14 equals 0. Okay? That's just something you can see quickly to do. All right, so let's put all this in the calculator, but we need to have table. All right, yeah, I'm just going to type the whole thing in. I could just do a type over, but I'm not going to do it. 2x minus 4 in parentheses, the 3 minus, I need a fraction, 5 over 3, arrow over, put in my x, close my parentheses, and now I need my minus 14. Push enter. Yes, we need to start at 0 and steps of 1 because you see our a and b are whole integers. They're just integers. Okay, let's keep entering till we get it. Okay, now, oh, that's going to be a little challenging. We need to find where the 0 is here. Ah, there it is. There it is. Right there is what we need. 3. X equals 3. X equals 3 because it is accompanied with, sorry, I should have written, because if you have X equals 3, then everything would equal 0. This 0 over here is very important. We're looking for the Y to be 0. So we're really looking for this over here. So now that we found it, we have a value of 3 to put in, and we also see that we probably just need B, okay? So let's back out of our table function, go second mode, and now let's put in 3 minus our fraction, 5 over the 3, arrow over, and I'm going to put this in parentheses, the 3 that we found, and then we think it is in our B option. So enter negative 2, B has been verified. Okay. Now that's just a way, if you watch the other videos with me, yes, you could use elimination. This is just a way of using substitution to quickly have a way to put it in the calculator using what I have, and it saves some brain function. You're taking a test. Do whatever you need to do to go as quick as you can and use as little brain power as you can in these type of equations that, it's a system of equations. It could, if you try to do it all by hand and make a little mistake. I know you've been there. We've all been there, and you're frustrated and you're like, what did I do? Well, this might help out, okay? But don't forget to write some things down so you keep up with where you're going. See how I did? I wrote it down and put arrows where I needed to let myself, remind me, hey, you need to do this. This is what you just did, okay? Anyway, that's the end of my rambling on that. Let's look at number 6. Okay. Find the solution to the following system of equations. Okay. Well, they're a little suspicious here because I have 2 here and 2 here. That's almost like handing it to me. I don't know about that, but I'm also seeing something else. If we divide the second equation by 4, it looks very similar. Okay. All right. So let me see. I'm thinking these have the same slope. Let's go ahead and follow through on that. The first one would be y equals 2x minus 3. That would be the y-intercept form. And the second one is, okay, all right, drum roll. No, I'm just kidding. Okay, let's see here. I have negative 4y equals 1 minus 8x. Now, as I said before, if we divide these out by, I said divide by 4. Well, to solve it all the way, we need to divide by negative 4, and that would be each one. What do we really get? We get y equals negative 1/4 plus 2x. And yes, I see the exact same slope. If these have the same slope, then obviously there's no solution. All right. So I'm going to say that's not it. And I'm going to go with no solution. Now, you could verify this very quickly. You could, okay, bear with me. You could take this and then put it in here in the calculator doing what I did before. We would have 8x. Remember, you have to, if you uh, change the form of the first one, then you substitute into the second one. If you don't remember that, you notice that's what I've been doing. Okay. All right. So minus 4. Okay. And then I would have 2x minus the 3 minus 1 equals 0. Let's put that in our table and see what it looks like, okay? Let's see what happens, okay? I've done this in other videos, all right? So I know if you don't want to watch it, you can skip past this part, right? That's the beauty of video, right? Okay, 8x minus the 4, and then 2x, okay, minus 3, close it, and then we need minus 1. All right, let's push enter, and let's start at 0, go by steps of 1, because I'm seeing whole numbers over here. We're trying to see, is my answer good? Oh my goodness, of course it is. It's very correct. Look, all we get is 11. That's a clue when that happens to you, that there is no solution and we do have parallel lines, okay? I just wanted to show you how to identify it on your calculator. So the next time you see that happening, especially during a test, be wary. Okay, if they don't have no solution as an option, then you've done something wrong, okay? All right. This is the last question in this video. Thank you for watching and bearing with my little bit of extra tidbit opinions and making it all the way to the end of any of my videos. Thank you very much. And thank you for sharing and liking and subscribing. I do wish you happy testing.